Let's discuss data warehouse in this section. So what is data warehouse? A data warehouse is centralized repository of integrated data from one or more disparate sources. Data warehouses store current and historical data and are used for reporting and analysis of the data. Data warehouse basically is like the definition says, a centralized repository, and all data from the enterprise will get into this data warehouse will be stored in here. So it's a central collection of everything, all data of the enterprise. It stores data in a format that is optimized for reading and analyzing. It stores historical data from multiple systems and stores the lowest level of data with aggregated view provided in the warehouse for reporting, and allows the transactional system to focus on handling writes while the data warehouse satisfies the majority of read requests. There are 2 points in all this discussion. First of all, data warehouse oops, stores historical data, store the lowest level of data and stores all the data. So it's like every data generated in the enterprise should be stored in the data warehouse. Then secondly is the data warehouse will satisfy the majority of read requests, and the data is stored in a format that's optimized for reading and analyzing. So data warehouse is used for data analysis. It's used for data analysis, and this analytical nature makes the number one request reading. The data warehouse is the organize the view of all data in the enterprise. This organization is created to facilitate reading and analysis. The eventually data warehouse is you build a database and dump everything into it, and then organize that in a way that you can read in a logical manner, satisfying the business need. That's what data warehouse is. But there's an issue with what we just discussed, right? Just because the data has all a database has all the data of this company does not mean it's a data warehouse. So after you collect all the lowest level of data and collect it for historical data, you have the historical lowest layer of data there. You still need to organize that. You must properly organize based on analytical needs. This organization can be like a certain normal form or hierarchical modeling, but somehow it needs to be organized so that whoever running the analytical job can actually seize their job. You can seize the data and analyze that in a way that meets your need. So contrasting to a data warehouse is the idea of operational data store. Operational data store is similar to data warehouse in the sense that it's also a central database that provides a snapshot of the latest data from multiple transactional systems. And sometimes it can have historical data. Mostly, data store is a collection of current or recent operational data of the enterprise data. So it's also enterprise data, right? A collection of all enterprise data, but it may not be historical. It may be just the recent 3 months or 1 year. Instead of usually in the data warehouse, you are talking about several years. There are, however, some mix and match here between ODS and the data warehouse. Some ODS does contains historical data, so this is not a strict definition. So but why do we have? How do we get the ODS? Because most current business applications, right? Currently, most of the business applications run on top of a relational database. They use relational database as their transactional system, and usually, some those relational database are some common databases like Oracle, SQL Server, Postgres, right? So modern technology allows these database to be copied into a separate database. So if you have a transactional system running, either in SQL Server or PostgreSQL, there are technical ways to duplicate the same data, maybe with a few seconds of delay, but you can copy the majority of the data into a separate database. And you can read from this database for online analytical purpose. So that's when you can have all the data transaction systems, all their data get duplicated to one centralized database, thus forming the central collection of your enterprise operational data. The difference between this one and the data warehouse is, first of all, because this is a copy or some sort of a copy of a transactional system, it won't contain historical data, because if you have too much data in that, even copying the performance will get hit. So usually ODS does not contain all the historical data, but as we just said before, there are some ODSs that was specifically designed to hold historical data. So this is not a strict line, but the more a more a real division between ODS and the data warehouse. A real difference is that data warehouse are organized by for analytical purpose. It usually is designed around a certain analytical need, whereas ODS is a direct copy of a transactional system, sometimes with some kind of transformation. There may be some transformation and aggregation happening, but still the organization, the distinctive difference between ODS and data warehouse is that ODS is arranged by source system. If you are getting data from your source system, doing some internal processing and arrange them based on source system, that's ODS. Only when you break the difference, the border between, only when you break the wall between different source systems and combine data from different source systems into one, that becomes data warehouse. But that does not mean that you cannot use ODS for active reporting, right? You still can do operational reporting, and you can also use that for warm backup and redundancy. Like we just mentioned, ODS can have just a few seconds of a difference. And data warehouse is subject oriented. That's what we're talking about. As you can see, the operational analytic applications, they have order processing, consumer loans, consumer billing. All these each comes from one source system, and that's forming a ODS. But if you can break this up, right, based on customer, you see you break those ODS repositories up. For each customer, I have sales. These sales may include loans and the claims and orders, right? And then for customer, I have customers who borrow the loans, who had claims, and who had orders. Some customer may only be in one or two subject area, but if I want to create a data warehouse, I may be combine all these customers into one single dimension. So it will be a custom dimension. Some customers have a presence in one or two source systems. Some customers may have a presence in multiple source systems depending on their activity. So that's when you break the wall between the barrier between source systems and merge them into a data warehouse. You're ready for analyticals. And on top of analytics, every time you do analytics, you also want to have some actionable steps, right? Example is if a customer already has some order with us, but never has loans or the claims, should we reach out to them and try to sell our consumer loans? So this is something that definitely it will only happen after you break a barrier between source systems and identify there are customers that had orders but do not have loans. Right. So this is the meaning of data warehouse. But for operating system, operational data store, you can run individual run like who has an outstanding loan at this point, who has the order that has not been paid, who has claims that we have not paid them. So these are operational reports versus analytics that you can do in data warehouse. Further down the pipeline of data warehouse, there's a data mart. Data warehouse can be a central storage, but there are many different. But you only store the data in one format, right? But there might be many different ways of analysis. We talked about star schema before, and we talked about the enterprise bus. For each business activity, for each business flow, there are the facts and there are attributes. This is when and for different business flow, they have different fact and attribute. You cannot always arrange your data warehouse to meet all the needs. And even if you can create such a schema, your data may not be necessary. For example, if for quick analysis, you may only need 1 year of data, or you only need data from holiday shopping season. Data warehouse absolutely need to store all data, right? All months, January, February, March, etc. But what if you only want to analyze the holiday season orders? What if you only want to analyze the customer behavior in like the 2 years of a pandemic? That means or if you only want to analyze a specific session based on whatever criteria. That means you need, in order to improve the performance, you don't want to run your query against the whole database, the whole data warehouse for this specific analysis. In order to do that, it's a common practice to create a data mart. Data mart is a projection of data warehouse. Based on your analysis need, you will just cut a small portion, either a small portion of data or a small portion of columns, tables and columns, or a combination of both. You may be having this sales out of the data warehouse that we just see. We have a sales, customer, etc. And in this data warehouse, the data mart, we only get the fact, only three of them. And this is apparently just a sales. Probably does not include like claim processing, right? And then we have a custom dimension, we have a product dimension. These are coming from the data warehouse too. But this could be only the sales in a certain time, certain period, on a certain region or under certain conditions. So these are the data marts that you use to satisfy one specific need. And the data marts are usually arranged in star schema based on the enterprise bus that we discussed before. There are many different opinions, though, on how you want to define and implement data warehouse and data mart. The data mart certainly will always be star schema because that's what it is supposed to be. It's created for analytical purpose. But when you combine with the data warehouse, which one? What's the layout? What's the combination of a data warehouse design and the data mart? There are many different options. I'm just coming up with three, in my opinion, the three most popular ones. But feel free to come up what you think is suitable for your situation. The first one is for data warehouse. It will be a third normal form compliant relational data warehouse. And it should also it's still no matter which option you choose, the data warehouse should always contain all historical detailed information, right? Just that in the first option, it's a third normal form compliant relational data warehouse. And I think whoever one of the most famous person who has this opinion is Bill Inman. He is one of the leading the data warehouse experts in the field for so many years, and that's his opinion that the data warehouse should be a third normal form compliant just for storage. And then you build different reporting repositories on top of that, or data marts. In our terms, it's data marts. Another approach is the considering data warehouse because data warehouse is not only operating data store. You are breaking the barriers between source systems and combined data. So since you already are combined data, why don't you use a star snowflake schema in the data warehouse? Then the there are many people doing this too, and the concept of that is if you do that, then data mart will be a natural part, natural follow-up, just a projection of your data warehouse. Or in Ralph Kimball, there's also another people who, famous data warehouse advocate whose name is Ralph Kimball. He's as famous as Mr. Bill Inman. Mr. Kimball's idea is that you should start with the analytics. You should start with the purpose, the goal in mind. Then create data marts. The define, not necessarily create, but define data marts, and based on data marts, you work backwards to see what's needed what's needed in data warehouse, and form your data warehouse accordingly. Either way, either way, data warehouse should contain all historical lowest level data. There's no dispute on that. It's just that what schema is best suited for data warehouse. A common way that's not that is also supported by some people, some more practical data modeler, is what we call logical data warehouse. What is happening is they are not building a new data warehouse, but because you already have ODS, so their suggestion is you just create a series of a third normal form layer of view, or maybe start the snowflake schema of view on top of ODS. Because when we say the transition between ODS and data warehouse, we are saying we are breaking the barriers among different source systems and organize data in data warehouse. And if your ODS is simple enough and regular enough, does not have those weird architecture or relationships, then it is possible that you can create the views on top of the ODS and form data warehouse views. This is called logical data warehouse. Now, the problem with logical data warehouse is, first of all, it's basically a combination of ODS and the logical data warehouse. So you need to have, you need to have historical data in ODS. As we said, many ODS, in order to improve performance, or by its definition, by its design, only contains the recent data. But if you want to implement logical data warehouse, you necessarily need to have historical data in ODS. So this may be a management and storage concern or performance concern, right? Then you build a warehouse, a view on top of the ODS, and that's increasing complexity. But of course, the first two options both require you to create a brand new data warehouse, which can be a lot of hassle too. So there's no right or wrong. It is just like depending on what best suits your need and your situation. So now talk about what can be done with data warehouse. By data warehouse, the purpose of data warehouse has always been analytics. And over the years, there's this term business intelligence that came up closely associated with data warehouse. So, business intelligence basically is strategies and technologies used by enterprises for the data analysis and the management of business information. And the business intelligence, usually, I would say maybe 99% of business intelligence is built on top of data mart or data warehouse. There are many different terms in this field. From the very beginning, there's something called decision supporting system or DSS. Then there's some kind of like data analytics. These days, people start to like to use the word data. So data analytics, data analysis, data science, each come with similar but somehow slightly different meaning. In this course, we will use them interchangeably because the difference among them are too trivial for our course's consideration. We are engineering course. As data engineers, our concern is to provide data for their use. How they use that, the difference between these definitions is basically how they want to use the data. To us, it's the same. Someone want to use our data, so we will use these the terms interchangeably in this course. But but you should know that when people use these different words, sometimes they mean the same thing, but sometimes there are like minor differences you need to pay attention to. Now let's see what is included in business intelligence. There are many different levels of analysis that you can be done based on data, right? Starting from uh, bottom left corner, there's dashboards, which is the summarized information. Summarize the information based on your historical detailed data, but then you aggregate them and identify certain trends, certain patterns. That's dashboard, like a very high level, 30,000 foot height view. You look at as if you are on airplane and looking down on the ground. But then you only see large patterns like mountains or rivers. But if you dive deeper, get closer, you will see some details. Like this river, there's a dam on that. There's a small creek joining. There's a house near this creek, and someone paddling is a boat there, right? So these are the standard reports. Standard reports are used to because a lot of times the business activity is known, has a known pattern. You know what's going to happen. You know what happened. You know what's going to happen. What you are not sure is how it happened. So you can define some templates. What should be reported? What do you want to see? These are the standard reports. Like every day, if as a e-commerce company is a CEO, you want to see how is our sales? Did we sell better than the same day last year? Do we sell less? Even if we have the same sales, are we getting the same profit? I'm making the sales, but at what cost? So these are the information you want to see for first day at a glance. Then you want to, this is a dashboard like thing, but then you want to see, okay, naturally next question is if I'm not meeting the requirement, if I'm not meeting my goal, why? Then you want to break down to different stores. Oh, this store is not making profit. This product category is not making enough profit. This is standard report because you already know you have that much amount of store, or you already know these are the product categories that we sell. So you can create reports to report the performance of these stores, these product catalogs. Those are predefined, and the following clearly define the analysis path. As you look at these, there will be questions coming, right? And because the no standard report can cover all aspects of business, you have to dive deep and you have to ask questions. You want to see, oh, this store is not making money. Why? Is that because there is a promotion? Is that because there is some kind of a natural disaster happening around there? Is that because there is some event going on? Or is that because there is a competitor opening a new store which attracts 50% of the regular customer? So these are the things you want to dive in, but this cannot be included in a standard report because nobody knows which one is relevant. You cannot include everything on one sheet of paper. So that's when you have ad hoc reports. You get a data. You want to look into the different dimensions of a data warehouse and identify. That's what we call the ad hoc report and the analysis. Sometimes it's also called the OLAP, online analytical processing. And then followed by that, that's the analysis. You got the reports, you got data in your hand. Those data are now organized, ordered, sorted, filtered, and pivoted. You want to do your analysis. Then from your analysis, you identify, oh, maybe it's because this store is not making enough money. Maybe because there is a new store for our competitor in nearby, which attracts some customers. So you want to do some planning and forecasting. Forecasting like if the trend continues, we are not going to meet our goal by 5% or 10%. And then you want to do some planning and do some predictive analysis. planning such as, okay, let's do the marketing campaign. Let's send our customers a promotion coupon so that they will come back to us. We will promote, let's say we want to promote ice cream, but at the same time, we will secretly increase the price of our other products. So when customers come in for ice cream, when they buy other products, we make up the loss we had. So we attract the customers and we make up loss we had by running an ice cream campaign. So these are the planning and forecasting. Then you will also do some predictive analytics. By doing that, how many customers can be attracted? If like 10% based on our previous experience, when I run the ice cream promotion, this many of a customer will come back. So that will how much money can we make? How much profit can we make by this? So this is a series of analysis, different levels of analysis, which we usually call a storyline or exploratory data analysis. You just starting from some simple number, identify the pattern, identify the issue, and perform analysis and come up with a hypothesis and action plans. So these are the things that you can do for level of for analysis. And here is basically example of what we have. And these days we also we already covered dashboards, standard report or operational report, ad hoc reporting in the OLAP, data analysis, planning, and forecasting. And these days, a lot of companies are also trying to get the machine learning and artificial intelligence into their toolkit, trying to identify more customers. If you guys use, so example like if you guys use TikTok, I think the question is not if you guys use TikTok, it's like when you guys use TikTok, you must have noticed that its recommendation is based on your browsing history, right? If you see a cute cat video, you stay there until the whole video is finished. Then it will keep on pushing you a uh, cute cat video, and maybe they will give you a cute dog video. Just see what's your reaction. If you slide away from that cute dog the video, as soon as you see that, then it comes up with a conclusion that you are not interested in dog. So it's not going to show you dog videos. These are the machine learning and artificial intelligence they are trying to implement inside their algorithm. And these levels of analysis definitely requires more data and more processing power. And that's actually some ideal jobs that you guys want to look for. So those are some examples of like you have the pie chart showing the portions of sales, and you have the bar chart and the scatter dot chart, everything. Then from here, it's hard to see exactly what's going on, right? But based on the pie chart, based on like scattered chart, scattered dot chart, you can identify some kind of pattern. And especially if your dashboard is designed good enough, it will provide you with some alert and warnings on, on trends that you want to identify. So that's a separate topic that we are going to cover in week 9 when we talk about visualization. Then that's standard report, right? Breaking down large chains, large categories into smaller ones, so that you can see in further detail. And then you do analytics by you can run this ad hoc reporting by use a tool or by using some kind of data science studio. This is the Azure Data Machine Learning Studio, in which you can use a Jupyter notebook running against data in Azure and somewhere else. Basically, what it says is you can run Python code and run your own Python code and perform your analysis. And finally, there are like machine learning and artificial intelligence services. Um, there are a bunch of different catalogs. We will cover them in our week 10. So, talking about the majority, talking about the data warehouse, right? We talked about what is the data warehouse, and we talked about what the data warehouse can be used for, which is business intelligence. These two terms are so closely related. When you try to look for a job, when you search for a data warehouse, very likely you will see business intelligence or data analytics, and vice versa. So, what are the major players in this data warehouse field? So traditionally, data warehouse, there are two types of data warehouse. One is you can use general purpose relational database with some kind of a data warehouse support, mostly joining and aggregation support, data retention support. Normal the relational database also have support features for better joining and for better aggregation. But the data warehouse has its own way of joining, which is as we see sometimes it has a star schema for data marts, and it requires a lot of more aggregation than normal relational database. That's when you have some kind of features specifically developed for data warehouse. So, like Oracle or like IBM DB2, they have the extra features that you can implement to enhance the hierarchical or star schema join performance. This is the general purpose relational database. There's also purposely built data warehouse. Those are like hardware and software specifically built for great performance of data warehouse operations. Two examples, Teradata and IBM Netezza. So let's look at a traditional data warehouse layout. It's a Teradata layout. In one cluster, you have multiple nodes. Each node is predetermined CPU, memory, and the hard disk somewhat like our virtual machine, but usually for Teradata and Netezza, that will be their own dedicated hardware. And so in this Teradata Vantage site, you can see there is some kind of a monitoring of a SQL request and answer response tracking based on their Teradata parse engine. Then this parse engine will handle the data jobs to different nodes. Will spread that out on a data node. Originally, when this architecture was just fresh invented, people using a symmetric architecture, which means you either have two nodes, four nodes, 8 nodes, 16 nodes, all to the all 2 to the power of n. But as technology advance, this is no longer required. You can have arbitrary number, but it has to of nodes, but it has to be predetermined. So the problem with this approach is the compute and the storage are tied together and they are predetermined, right? The problem with compute and the storage tying together, each node have the preset amount of CPU, memory, and storage. Is that in a data warehouse world, compute and storage don't usually come together. They don't. They grow separately. You because most of the analysis is the same year over year. It's like you are going to handle this year's sales, this month's sales versus last month's sales or last year's same month's sales. So in this case, you are the amount you want of data you want to process is the same year over year. It will be the same analysis this year versus last year. However, your storage does not accumulate over in one day, right? So when you start your data warehouse projects, very likely you will have to define the compute need for all 5 years or 3 years that's coming. When I buy the machine, I need to have enough compute power to handle my previous sales and this year's sales. That's determined. And the next year, I will still have the same requirement, same need for compute. But this year, I may only have 5 years of 2 years of historical storage because I just started my data warehouse project. But after 4 years, these 4 years plus 2 years, now I have 6 years of data storage requirement. So storage increase constantly and steadily, but compute, you have an upfront requirement. These two does not match each other. And in the future, when you have more things happening, when you require more analysis, you will definitely need to increase your compute need. Whereas your storage is still growing in a steady pace. So your compute and storage are each have a different growth pattern, and this is not cost efficient if you want to tie them together in different nodes. So the issue then, the solution, of course, is to separate compute from storage, right? I think by this time you have already heard enough of separation of compute and storage, and this basically is something we start talking about from the very beginning of this course, right? That's when you have the cloud data warehouse, which by its based on its natural source, it does have that compute and storage separation. Right? The three cloud data warehouse we are talking about is Snowflake, Google BigQuery, and Amazon Redshift. These are the three main major data warehouses in the market right now. The first is Snowflake. Snowflake is probably the single most successful cloud data warehouse currently in the market. It's cross cloud vendor. You can implement a Snowflake. It by itself, it's a data warehouse system. You can implement this in Amazon AWS, Azure, or Google or GCP. They follow the same pattern in different clouds. Right now, it's the most popular cloud data warehouse. It's a traditional data warehouse. So what I always say to tell my customer is, if you come from an enterprise data warehouse world, and you are looking for enterprise data warehouse in the cloud, then Snowflake is probably the one thing you need and the only thing you need. It just does things like that. It's a complete offer of enterprise data warehouse sitting on top of a cloud. So if you are looking for a data warehouse, it's a perfect solution for you. But it's only a data warehouse. So, and the issue with Snowflake is it's expensive. It's just like every data warehouse project. It's expensive, and the problem. This is beyond technology, but the problem with a Snowflake implementation is why is that expensive? Because if you think about a data warehouse implementation project, data warehouse requires data from all sources, right? But these sources you cannot get them in together. Usually, what happens is the first year it's a 3 year, 2 year or 3 year process project. You will get the data from maybe 4 data sources this year, 2 more next year, and 5 more the third year. Um, Snowflake usually construct their contract in a way that you have a lot of discount in the first year, and you will be charged the regular price as third year. So, but the first year, because they charge pay as you go, first year you don't have that much amount of data because you don't have that much amount of the data source. So you have less data and you have a huge discount from Snowflake. You may think this data warehouse is cheap, especially for companies, financial controllers. They look at the first year estimate and they think this is cheap. But at third year, when you have all your data and Snowflake is charging you full price, that's when you will really feel it's expensive. So of course, if you are a big customer, you can negotiate with them and get a better price again. But that's a different story. That's a different story, and it all depends on what you are capable of doing. With that, um, Snowflake is trying to have, let's go back to the technology side. So Snowflake has the idea of storage and compute separation. You see this processing part. Of course, as always, we again have three different layers. The first one is the administrative one, right, which is called cloud services here. And as you can see, it's authentication, access, optimizer, security. These are infrastructure manager, those kind of administrative work. Then you have the compute layer. These are just virtual machines running queries against storage. Data are stored in the storage layer, or here is called database storage. The query processing are done by virtual machines. Virtual machines run against different the services. So you can define your virtual machines, or here is called a virtual warehouse. Fetch data, doing all your processing, and you can you use another virtual machine running against the same data. This is what the Snowflake can do in parallel processing, right? You can run different multiple queries against the same data at the same time. And I actually wrote a blog, understanding parallelism in Snowflake, regarding how Snowflake achieves its parallel. So the link is here. Now, next one, Google BigQuery. Google BigQuery is actually, in my opinion, more advanced in technology than any other peers. So as we saw in Snowflake, the compute is still defined by virtual machine, right? The storage and the compute are separated, but the compute is still defined by virtual machine. You cannot increase the size of virtual machine, and once you define a virtual machine, it stays there for a while unless you explicitly close it and provision a new one. Google does not require you to provision virtual machine at all. In Google's case, the storage and compute are separate. You have data stored in Google's cloud storage, which is equivalent of an Azure storage account. That's no problem. Then you have but Google does not have the concept of something called the data warehouse. The warehouse and virtual machines. Instead, Google will calculate and estimate the required compute power, assign virtual machines, virtual CPUs to you directly. So there's much more flexibility and control over the virtual on the compute power, not limited by virtual machine. This extra layer of virtual machines. So it's really, I think, it's more flexible and more scalable than any other offerings. Uh, but it's the most powerful and the flexible cloud data warehouse, in my opinion. Of course, Snowflake salesperson may disagree. then, but there is a problem, which is Google BigQuery is a Google technology. Now, personally, I like Google technology, but at the same time, as a cloud architect, I also agree that Google's technology is a little bit complex, more complex than other vendors. Probably not a little bit, but somehow more complex than other cloud vendor. So that's why I put here Google technology. The terminology that this is a Google technology can be both a blessing and a curse. There are people, once they heard it's a Google technology, they refuse to use it because they think it will cost them too much. The learning curve is too deep, too steep. So it depends on what you want. Personally, as a techie, as a nerd, I like Google technology, but as I wear another hat as the cloud data architect, recommending solutions to our customers. I do understand some customer may not be ready for Google technology. They would like to choose something that's more managed and simpler, easier to manage. Then the third one is Amazon Redshift serverless. Amazon Redshift has been there for a while. So if you look at the Amazon Redshift the offerings. There are actually multiple offerings. The Redshift serverless is the latest one. Before the Redshift serverless, there were like a traditional nodes where you have the idea of nodes, and each node have a combination of CPU and memory. You will define, do I need 2 CPU and this much of a memory, 32 CPU of this amount of memory. Those are like more for existing database support. The most advanced, most current offering is Amazon Redshift Service, which pretty much follow the concept that we discussed during when we talk about Snowflake and Google BigQuery. So we're not going to dive deep into this, but pros and cons of this Redshift. The the issue, this is to talk about issue first. The issue with this Redshift is it's simple. It's very, very simple. It's much less complex and much less flexible than Snowflake or a Google query, BigQuery. Let's say the technology-wise, it's just a very simple how do I put it nicely? um, it's not advanced, technologically advanced and capable as Google BigQuery, and it's not feature-wise. It's not as the offering is. It does not match all offerings by cloud by Snowflake. So that no wonder Snowflake and the Google BigQuery is probably are the two most popular cloud data warehouse, right? But why would we pay attention to Redshift? Because it is a part of uh, Amazon's data ecosystem. Redshift itself, or Amazon, does not brand Redshift as a single standalone data warehouse. Rather, Amazon provides a whole ecosystem of data processing power. So the key here is when you purchase from Amazon, you are not just getting one Redshift. If you just getting one Redshift, then it's really a mediocre data warehouse product that can meet some of your needs. It's cheap, it's stable, but you cannot expect anything other outside of running a SQL and get data. But then you have much more things in the Amazon ecosystem. You have the Amazon Data Lake, you have the Amazon Athena query engine, you have the Amazon Redshift Spectrum. A lot of things that you can utilize to build a data ecosystem uh, with a relatively low cost and expandable and scalable support. So when you look at Amazon, don't think you are comparing Redshift to Snowflake or BigQuery. Rather, it's the full package offered by Amazon. So these are things that these are the three most popular data warehouses, cloud data warehouses, and how I look at them. As we all know, cloud technology is developing rapidly. So all these statements can be wrong at any time. So make sure you do your own investigation if you ever need to choose. Don't just rely on what I just said because this can be outdated very soon.